Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know for next Tuesday's test. So don't stress, there isn't too much to know. It's just on solving some equations. Remember, equations have an equal sign, and we're looking at equations with one variable or pronumeral, i.e. letter. So we're looking at things like this: x plus 1 equals 9. Now this is a very easy equation, I know. So our goal is always the same. We want to find a number that we can substitute for x to make this statement true. Of course, in this case, there's only one number we can substitute for x to make this statement true, and that is, of course, x equals 8. Because if I change x to 8, I get 8 plus 1 equals 9, and that's a true statement. If I substituted any other number, say x equals 6, then I would get 6 plus 1 equals 9, not a true statement. So x equals 8 is the only solution, and the equations that we're looking at have one and only one solution. So we could have another equation like 7x equals 42. Of course, if no operation is written, this means it's times. So we're saying 7 times what number equals 42? Now, if you didn't know off the top of your head, that's fine. What you can do is undo the operation that's been done to x. So we undo adding by subtracting. We undo subtracting by adding. We undo division by multiplying. And we undo multiplying by 7 by dividing by 7. We can do whatever we want to one side of the equation as long as we do the same to the other. So I can divide 7x by 7 to get x, as long as I divide 42 by 7 to get 6. So if you're stuck, remember, we're just undoing everything that's been done to x. So these two equations I've written up are both one-step equations because there's only one operation that's been done to x and one operation we need to undo. When you're solving one-step equations, you don't need to show you're working out. But we're now going to look at two-step equations where you will need to show you're working out. So if we look at this equation, 2x minus 1 equals 7, it's a two-step equation because we've taken x, times it by 2, and then subtracted 1. So we've done two things to x, and there's two things that we need to undo. Now, when you come to undoing operations, you undo them in the opposite order to BODMAS. Because of BODMAS, I would have times first, 2x first, and then subtracted 1. So first multiplied, then subtracted. So that means when I'm undoing, I need to undo this one first that was done last. It's like when you dress yourself, you put on your shirt and then you put on your jumper. So when you undress yourself, you have to take off your jumper first because you put it on last. Then you take off your shirt. So it's the same here. What we've done is we've dressed x by multiplying, then subtracting. So to undo that, we have to do it in the opposite order. So I undo subtracting 1 by adding 1. So I'm going to add 1 to the left-hand side. But what I do to the left-hand side, I must also do to the right-hand side. So if I add 1 to both sides, on the left-hand side, minus 1 and plus 1 cancel out. They just equal 0. So I'm left with 2x. 7 plus 1 gives me 8. But I still haven't finished because I haven't got x equals something. So now I'm going to undo timesing by 2 by dividing by 2. And what I do to one side of the equation, I must do to the other. So the answer I get is x equals 4. And that's because if I take the equation 2x minus 1 equals 7, and I substitute x, change it to 4, I get 2 times 4 minus 1 equals 7, true statement. That's how I can check my answer. So we've also gone through two-step equations involving fractions. So let's say we have some fractions like this. So these probably look very similar to you, these two equations. They've got the same numbers, the same operations, but they actually differ only in a very small way. And that is order of operations. Order of operations makes all the difference. So even though these two equations both have the same numbers and the same operations, the order being different means they are going to have totally different solutions. So in this top one, we've taken x and subtracted 8 first, then divided by 3. So when we're solving, we have to do things in the opposite order. We have to times 3 first because it's the last thing that I did to x. So if that's the case, if I times by 3, don't times the top of the fraction by 3. The divide 3 and times 3 cancel out. So I'm left with x minus 8 equals 2 times 3, which is 6. So what I should do is work down the page, and I should keep writing the equivalent equations. So if I add 8 to both sides now to undo subtracting 8, I get x equals 14. That's my final solution. So I'm done with that equation. Now let's solve the second one. So here I've taken x divided by 3, then subtracted 8. So when solving, I need to undo subtracting 8 first. So I add 8 to both sides. So those will cancel out. And I'm left with x over 3 equals 2 plus 8, which is 10. Now I times each side by 3. So working down the page, showing exactly what's being done to x, I end up with x equals 10 times 3, which is 30. So the solutions were different. X equals 14 and x equals 30. So that hopefully shows you that if you do things in the wrong order of operations, you will get the wrong answer. So you have to be careful about that. All right, we're now going to go and look at equations with brackets. So let's say we have something like this. 2 outside of x minus 5 equals 24. So the brackets just change the order of operations. So in this case, if I just wrote it without brackets, if I just wrote 2x minus 5 equals 24, I would be timesing x by 2 first, then subtracting. But here, the brackets mean that I'm subtracting 5 first, and then I'm timesing the answer by 2. Now, you could actually solve this equation here without needing to expand the brackets. However, there are some cases, and I'm going to show you in a moment, where you have no choice but to expand the brackets. So my recommendation is, if there are brackets, your first step is always to expand them, just for simplicity. So remember, the way we expand the brackets is the distributive law. We distribute the 2, the thing outside, to everything inside the brackets, 2 times x, and then we go 2 times not 5, it's 2 times negative 5. So we get 2x minus 10 equals 24 after expanding the brackets. You've done these a million times. We undo what's been done to x. We need to add 10 to both sides first, because we're doing things in the opposite order to BODMAS. So I get 2x equals 34, and of course, the way I undo timesing by 2 is to divide each side by 2, and I get x equals 17. So if I substitute x equals 17 here, I get a true statement. That's why it's the solution. But let's say I had something like this. So if I have something like this, the problem is that x is in more than one spot. It's here and here. So in this case, I have no choice but to expand the brackets and then collect like terms, because I can only use the principles I've just told you, only use the methods I've gone through in this video when x is in one and only one spot. So I'm going to expand each bracket. So first bracket, distribute the 3 to everything in the brackets. And I do likewise for the second one, but don't get caught out. This is not a 2, it's a negative 2. So I don't go 2 times 4, I go negative 2 times 4, which is minus 8. Use your calculator if you're stuck. And then it's negative 2 times negative 2x. Negative times a negative gives a positive. So that's after expanding the brackets. I haven't actually started to solve yet. I collect like terms. So I can't add 3x and 15. They're not like terms. But 3x and positive 4x are like terms. So 3x plus 4x gives me 7x. And then I've got 15 minus 8, which is 7 as well. So I get 7x plus 7 equals 0. So now I'm going to solve this. now that I've collected like terms, it's very easy. Subtract 7 from both sides. I get 7x equals minus 7, and then I'm going to divide each side by 7. Now here I get the answer x is -1. There is nothing wrong with having a negative answer. If your answer is not negative, nor is it a whole number, please don't assume that you've done something wrong. All right, now we're going to look at cases where the pronumeral is on both sides of the equations. So let's look at this equation here. Now we have an x on both sides of the equal sign, on the left and right hand side. Our goal is still the same. We want to solve it, meaning we want to find a number that we can substitute for x to make this a true statement. But as I said before, the methods we've been using only work when x is in one spot. Here it's in two spots. So the goal, when I have x on both sides of the equations, is that I want to get x to one side of the equation, and I do that by subtracting the x, or the letter, the pronumeral, with the lowest coefficient. Coefficient meaning number in front of. So this one here this x here has a coefficient of 2, this one has 6. So clearly, this one has the lowest coefficient. So I want to subtract 2x here to get rid of it on the right-hand side. But what I do to one side of the equation, I must do to the other. So on the left-hand side, I'm left with 6x minus 2x is 4x. The minus 15 hasn't gone anywhere, haven't done anything to it. 2x minus 2x is 0. Now that x is in one and only one spot, I can solve using the same processes I've been going through. So I'm going to add 15 to both sides to undo subtracting 15. I get 4x equals 15. So of course now I need to divide each side by 4. So x won't be a whole number in this case. It'll be 15 over 4, which is 3.75. But that doesn't matter. Just because I didn't get a whole number doesn't mean my solution is wrong. So let's look at another example now. So let's have a go at this equation here, which is quite tricky. So as I said previously in this video, if there are brackets, always make your first step to expand them. So that will help us get x to one spot. So distribute 6 to the 2x and 6 to, it's not 6 times 1, it's 6 times minus 1. And I haven't done anything to the right-hand side yet. So now you might notice this is a bit different because I have a negative 4x on both sides. So I'm not going to do this any differently. Negative 4 is lower than 12. So I need to subtract from both sides negative 4x, but that's the same as adding. Subtracting negative 4 is the same as adding. So actually I'm adding 4x to both sides. That will get rid of the x on the right-hand side. So I end up with 12x plus 4x is 16x minus 6, because 6 and 4x are not like terms, can't add them together. That equals, so negative 4x plus 4x cancel out. So I'm left with this. So now what I need to do is add 6 to both sides. And I get 16x is 0. So don't try and do this any differently because there's a 0. Divide each side by 16. You divide by the number in front of x. Some people in this situation would make the mistake of saying x is 16 divided 0. It's not. It's 0 divided by 16, which is 0. That is the solution here. Okay, there's one more little pitfall I just want to talk about and then we're done. So I just want to go through an example like this, which is actually easier. It's back to the two-step equations, but I wanted to bring this up because I've noticed a lot of people are making mistakes with ones like this. So I'm not going to do this any differently. I've got to undo everything that's been done to x in the opposite order to BODMAS. So I have 18 minus 3x equals 54. This 18 needs to be undone. It is positive. So to get rid of it, I don't add 18 to both sides. I need to subtract 18. Because if you have 18 of something, you need to take away 18 of that something to have 0 to get rid of it. So what I do to one side, I do to the other. So 18 minus 18 cancels out. I'm left with 3x equals 36. Now, a lot of people do this, but this minus belongs to the 3. It's not an x with a 3 in front, it's an x with a negative 3. So the negative is still there. So this is not 3x equals 36, it's negative 3x equals 36. Now, when you have something like this to solve, we don't divide just by 3, we divide by negative 3. The way you undo timesing by negative 3, which is what we've done here, is divide negative 3. So x will be negative 12. 36 divide negative 3. If you were to have something like this, say 7 minus x equals 10, we do this similarly. We're going to subtract 7 from both sides because that's how we undo the 7, because it's a positive 7, and we're left with minus x equals 3. If you have minus x equals 3, then what you can do is change the sign of each thing, because remember, what I do to one side of the equation, I can do whatever I want to one side of the equation as long as I do it to the other. So if I change the sign of x, I change the sign of 3. Another way of looking at that is I've divided each side by negative 1. Okay, so these examples are ones that people have slipped up on, and hopefully if you get one like this in the test, you now won't. So please feel free to ask me any questions before the test. Best of luck studying. This has been the luckiest maths teacher in the world. Have a great day.